Hey there, and welcome to Into the Terminal, episode number 54. We are just chugging right along. Welcome. Today, we are going to be talking about file system operations and file system layouts. And with that said, I want to turn it over to my esteemed co-host, Mr. Scott McBrien, to talk us through the critical path this morning.
Yeah, let's just jump right on in, Eric. So the first thing is, where do we find files? And then we're going to talk later about how they go different places. But our first command today is going to be which, and I think we're going to do a which SSH. And what which does is it takes a look at the path environment variable. So if you do a echo $path, all uppercase, the which command will take the argument that you provided, in our case SSH, and then it checks each one of these individual directory locations to see if that directory has a file that matches what you passed to which, and then it stops at the first match. So for SSH, is able to find that file in user bin SSH. This is really handy for knowing what command you're running or where the command you're running lives. All right, another command that we have for finding things is locate. So if we clear the screen and do a locate on fstab. So locate will take in a file name as an argument, and it will search for that portion of whatever you've passed to locate in the file name. So you see that we have one called etc fstab that is the exact name that we passed, but then there's also things like 95 fstab-sys. So locate actually uses a pre-built database that is built by a cron job, usually at like 4 o'clock in the morning. So that's one of the reasons why it returned so quickly, was it just queried this database and pulled out all the matching records. But because it's built at an odd time, what you might notice is that when you install a piece of software or you've created a new file, it will not be reflected in the locate output because it hasn't been added to that database that happens at 3, 4 o'clock in the morning every day. So this is great for a quick return, but it's not always accurate based off of what time the files were created. So we also have a command that will do a real-time search of the file system, and that's find. Find takes a whole bunch of arguments. So in our find command that we're about to run, it's find. You give it a starting location in the directory tree. So if you tell it to start at /, it will recursively search down through every file and subdirectory on the system. You can give it a bunch of selection criteria. So we're using name. So we're looking for files with a specific name. You can also look for files with different permissions or sizes or modification times. There's a whole bunch of criteria that you can use with find to find files. So we're looking for files that have something sshd_config. And that's all that we need to run find, which is starting point and selection criteria. But then we also added in the error redirection operator, that =, and directed all of our error messages to dev null. And the reason for this is that there are some directories that, as a regular user, you might not be able to get access to, or because of permissions and stuff in the proc file system or device file system, you may not be able to access or might not be searchable with find. You'll get a bunch of error messages that come out. So that's perfectly normal to see errors about not being access certain files on the system. And we just went ahead and said, throw all those away. Put them in the dev null special device that doesn't provide any output. And we got no output. Interesting. Let's try just star SSH star. So that says look for a file that has a name something, SSH something. Let's take off that first star. We'll get there. We'll get there eventually.
I even copied the command right out of the episode guide.
You did, and I've wrote it last night going, that looks right. Let's take off that =, let's see what the error messages actually say, if there are any.
Oops, took off too much. Oh, you know what? I wonder if it's something as simple as a copy paste.
Yep, copy paste.
Yep, there we go.
There we go. That's more than one. Oh, those quotation marks. So let's try one more time with our original syntax,
the original
but replace the copy pasted, with actual quotation marks. Here we go.
Hey.
Okay. So we're able to find this file called sshd_config, and it happens to live in the etc ssh directory. Whew, it was hard to get there. So that's how you find files on your system. But one of the things that I've also found is a problem is I want to run something. I type in the command, and it tells me command not found. So in cases we maybe have it installed, but we have to use something like locate or find to figure out where it's at, which. But it could be that it's not installed. So we could do something like a DNF whatprovides.
I'm afraid to copy and paste that command now.
All right, so what this is doing is it's going out to the configured repositories for this machine and looking for packages that will provide files that are named something unbound. And you can see that there's a bunch of matches there. So our packages are things like the unbound RPM, the unbound libs RPM. And so I use this a lot for finding something like a package that I may be interested in installing that is not currently installed on the machine. All right, and then if you still don't find what you're looking for, well, maybe it's because you don't have the right repositories enabled on this machine. So for example, if we wanted to look for TensorFlow, this machine would not show any results for TensorFlow because TensorFlow is provided by the extra packages for Enterprise Linux repository. And by doing a DNF repo list, we can see that this machine doesn't have the extra packages for Enterprise Linux repository installed on it. So knowing what metadata you're checking against is also kind of important for finding those interesting packages that you may want to install on your machine. All right, I think that takes us to the critical path, Eric.
It does. So now that we've talked a little bit about how to use find command, or how to find commands or find these supporting files, in the second half of the show, we're going to open up the Q&A portion. So this is your chance to jump in and say hello and to get your questions asked live on air. But we'll also be looking at the Linux file system itself and how to go about understanding the architecture of the Linux file system. So with that said, let's go ahead and jump into the second half of the show. All right. Welcome to episode 54, File System Operations. And, here we are, second episode of the year. We'll get it figured out again. Copy-paste quotes. Gotta love it. So before the break, we talked about finding some commands, but have you ever noticed that software packages provide a whole bunch of files, like just looking for unbound brought back a couple of dozen different results? And there's files in /var/etc. There was RPMs it referenced. So there actually is, believe it or not, a rhyme or reason to how the file systems are laid out. And you can start to get an idea of what files make up an RPM package using commands like RPM and DNF. So, Scott, do you want to continue with our unbound example, or do we want to move to something a little bit more common?
So the next couple of commands that we've got are basically like how you can get a list of what files are provided by packages, and then maybe we transition from there into talking about why they go these different places. So for example, if we do an RPM-QL, that's a query for a list of files with the package, in this case, HTTPD core. We'll see all the files that were provided by the HTTPD core RPM when it was installed. Right, and they are in etc, user, var, all different places around the file system. And there's a reason why they go in these specific places that we'll get to in a bit. You can also do things like if you are interested in what files will be provided by something before you install it. You could do something like a DNF repoquery. And so for our machine, we do not have Nginx installed. But if we did a DNF repoquery-L on Nginx, if we were to install Nginx from our software repositories, these are all the files that would come with it. And this is actually the same metadata that we use when something like a whatprovides, a DNF whatprovides actually looks at this same metadata to figure out what RPMs contain which files. All right, so if we look at maybe an ls of slash directory, you'll see that there's like a bunch of top-level directories, and we can go through and actually talk about why these are the directories that they are. So you want to tell us a little bit, Eric, about our standard that we use?
Sure. So, pretty much all Unix and Linux systems use a standard called the File System Hierarchy Standard, the FHS. And believe it or not, they actually have a webpage, and you can go out and read the dozens and dozens of pages on why these file systems exist and what each directory does. You'll notice some of them are. You'll notice that some of them nowadays are symlinks. You'll notice that others are no longer really in use, but that's just because Linux and Unix distributions tend to pull from this file system standard. It makes it really helpful as a systems administrator or a developer to go from system to system and kind of have a general idea of where certain files belong. So a couple of quick examples before we really dive in is, say, /dev. That's /devices. So hardware devices actually have a file system actually have a directory on the file system. A lot of configuration files end up in /etc. /var has a lot of log files, configuration files, but those are just a couple of examples. And obviously /home is home directories for users. So I'm really excited because we're getting very high tech on Into the Terminal. So Scott is diagramming for us today.
Yeah, and just to dovetail into what Eric was saying, so the Linux File System Hierarchy Standard is used by all Linuxes, but it's up to the individual Linux distribution to decide how to use those directories. And so what we're going to be talking about today is a very Red Hat way of thinking, right? This is how Red Hat and Red Hat-based distributions like Fedora, CentOS Stream, this is why we make the choices we make. But that may differ from other Linux distributions and how they choose to manage things. So I already put on here dev because Eric was kind enough to identify what goes into dev when he was telling us a little bit about the file system hierarchy standard. There are some other kind of gimmies. So Eric, what about this guy, TMP? What goes in there?
So TMP is short for temporary. I guess that E was just too much to type. So temp files are actually deleted upon reboot. So anything that goes into the temp directory, don't expect it to. Oh, did I misspeak?
So sometimes that is true. On certain Unixes like Solaris, that was absolutely true. But I don't know that that's the case for most Linuxes. It depends on whether it's backed by a tempfs or not. And that's something that maybe a little bit later we could take a look at the mount output for our machine to figure out what file system is actually backing that directory. And then,
well, there you go.
Eric, I'm sure you know this person.
So root, as we all know, is the administrative account on all Unix and Linux systems. And so the /root directory is essentially the home directory for the root account.
Yep. And so when root logs into the system, this is the place where they're put by default for their shell sessions. If they download files using things like Firefox, this is where those files would go. And this is really important for the Linux file system hierarchy standard, because in olden times, the slash directory was the top level directory. And so if you were logged into a machine and doing things as root, you would get all these directories and files and stuff at this top level directory structure, and it looks super gross. So with Linux, we actually take all of the root users' cruft and files they create, and by default, we stick them here in this home directory.
So we can
right, there's a couple
mark
other,
another gimme off the list.
yeah.
There's slash home, which is non-root users' home directories. I nailed that one.
You did. So we use the term home, but basically it's like a user directory. So if we look at the users that were installed on this or added to this machine, they likely have subdirectories here in home for their files and stuff. All right. So we're starting to get into more challenging ones, but there's a couple others I think that are close to gimmies. So Eric, how about this one? Boot.
So the boot directory is probably an area you don't want to spend much time in. That is the directory where all of the boot information goes. Go figure. So grub configuration, the init, not init RAM. Yeah, the init RAM image. A lot of the in fact, with RHEL 8 and into RHEL 9, a lot of what's in /boot is now either pulls dynamically from /etc or is symlinked into /etc, just to keep away from potentially making mistakes in the /boot partition.
Yeah, so we see things here like Eric said, the initial RAM disk files for kernel at boot time. We see grub information and bootloader information. This is also where the monolithic portion of our kernel is stored. So you'll see a bunch of files in there that are vmlinas. I see Shantanu beat me to it in chat. So that's the kind of stuff that we see down in boot, the files that we need to boot the operating system. All right, let's see what else we got here. How about this one? Media.
There's some interesting commentary going on in the chat. So /media, I think, used to serve a greater purpose. Nowadays, it's just kind of recommended practice to mount external drives, whether that's, say, a flash drive or an external hard drive, into /media then the name of the device.
Yeah, so it used to be the case that when we put a CD-ROM in, or we put a USB stick into the machine, it would get a subdirectory under media where we would access the files on that directory. But over time, the operation of things like the GNOME desktop environment has changed, and that stuff now goes under
/run.
I'm stumping Eric. Oh, I didn't stump him. He got it.
Haha. And of course, Nate, the Iron sysadmin himself, is hanging out in chat with us today, and he brings up a good point. Where I mentioned there's still some legacy pieces that are out there. So we have /media, which used to be for external media, which now goes into a subdirectory of /run. But what about /mount?
So /mnt?
Yes. Yeah, /mnt.
So this is a place to create what we call mount points. So if I was going to attach a file share into my machine permanently, what I might do is create a subdirectory in MNT with the name of that file share. And then when I attach the device, that's where I would put it into the directory tree. So if somebody's looking for these external things to my system, they could go into /mnt and they'd see a list of directories in there that correspond to different external resources attached to the machine. But again, things change over time, or how people use things over time become different. So we mentioned that media is where we used to put the removable media devices in the GNOME desktop, and now it's moved under /run. But who says that every graphical desktop still operate that way or picked up that change, right? So there might be graphical desktop environments that still use /media, or they create something in MNT. So that's where the interpretation on the part of developers or the person creating your distribution can come into play, where there'll be slight differences between distributions. Yeah, I see that Shantanu mentioned that he creates directories in /MNT for mounting things on his system. All right, so I think we've gotten a lot of the gimmies out of the way. Oh, here's one that we could probably guess based off its name. Lib.
So /lib and /lib64 are library directories. So you'll see a lot of supporting files and language dependencies that live in /lib. What's interesting to note is that lib64, bin, and sbin are all symlinks now that live under /user /usr.
Yeah, and you see in my my snapshot that I took out of my file manager this morning that there's a little like arrow on each of these, and that indicates that it's a symbolic link. And we'll talk a little bit about why that is the case on Red Hat Enterprise Linux in a moment. All right, so lib is for library files. Lib64 is for 64-bit versions of library files, or library files for 64-bit compiled applications. And then we start to get into some that are kind of weird, like this one and this one, bin and sbin. So we know that they're an abbreviation. Hey, Eric, what's the abbreviation for bin? Like, what is that abbreviating?
So /bin is short for binary, and that's where the actual binaries for these packages that you see exist. So if you have a command that you're running, something like locate or SSH, there is an actual binary file that lives in the /bin or /sbin directories. And those are both, as we mentioned a moment ago, are now symlinked under /user.
Right. And sbin also contains binaries. That's what the bin in sbin is. But the S is for sysadmin. And so bin was for like regular people's stuff. So you find commands like ls in bin because everyone should be able to run it on the system. Sbin will include binaries that were geared towards system administration tasks. So things like the fdisk command for editing disk partitions, that's in sbin. A lot of our daemon processes, like the sshd daemon, is in an sbin directory, although it's not in this one. So that's why it's called sbin, is because it was a logical place to put system administration related stuff. Now, it turns out if we looked at the file permission for things here, other people, not root, are also given access to these, but it's not in their path by default. Right? So when they run commands, they wouldn't find these unless they added it to their path. If they did add it to their path, they would probably still be able to execute most of them, but because they're running in an unprivileged way, they may only be able to do certain things. So for example, as an unprivileged user, you can use the fdisk utility, but you can only use it to list the file partitions or the disk partitions on a specific disk device. You would not be able to use it to edit things as a regular user. All right, and then we have this one. So this is also an abbreviation that we have lost to the history of the world. It is Unix System Resources. but we all pronounce it user, right? USR. This holds its name because of the fact that there were two flavors of Unix that was developed originally. There was the System 5 or AT&T version of Unix, and then there was the Berkeley version of Unix that was also developed. And so essentially, like in the Berkeley world, they used bin, lib, sbin, and all of the top-level directories. And in the AT&T or System 5 version of Unix, they put all those directories underneath the Unix system resources top-level directory. And so if we were to look into USR, and Eric, if you could flip back to the graphic as the main, if you were to look into the USR directory, you would see that there is a subdirectory called bin and a subdirectory called sbin, subdirectory called lib and lib64. And in Red Hat Enterprise Linux 7 and later, you'll notice that the top level directory on the system in /bin, /sbin, /lib, /lib64 are all symbolic links. If you do an -L, you can see that they point to their subdirectories in user. They have the same names. All right, so this is where we get a weird distribution choice. So in old-timey Unix world, you had one or the other, right? If you were a Berkeley user, your stuff went in the top-level directories. If you were a System 5 user, it went into user directories. But in order to maintain cross-compatibility between the different flavors, Unix has started adding. And so then you had to have all those on your path environment too, so that you knew to check in both places for commands that you needed. And that carried over into the Linux world, that we would have both /bin and user bin, /sbin and user sbin, and /lib and user lib. Because if we were coming from a Berkeley background, we might choose one over the other, or a System 5 background, we choose one over the other. We wanted to be able to accommodate both. But now we're carrying like these different directories with different stuff in them for no reason. And the idea behind the directories is the same, right? There's /bin or user bin. Both of them contain binaries. /sbin or /user sbin. Both of them contain system administration binaries. So why don't we just combine them? So we created these symbolic links at the top that point to under the USR header. So if somebody installs a package and in that package they reference that they want to put the file in /bin, still goes there, but thanks to the symbolic link, it's really stored in user bin. Same thing with lib. So essentially we were forcing all of our content down into the USR directory, but it operates the same for regular people, right? So all the stuff that you're used to in terms of path environment variables, compatibility between different Linuxes, that still all works, even though we're using symbolic links. All right. So we get a couple other weird ones here. We get var. So var is for variable length files. And you guys get to be have my terrible handwriting inflicted upon you. So variable length files are like, we could have a lot or we could have a little, and we don't exactly know. So Eric, what are some examples of files we find under var?
A lot of the log files exist under /var. And let's see. Back in the day, I did a lot of print spooling management as a Linux systems administrator. So the print spooler lived there. I think mail messages live under var as well.
Yep.
And then nowadays, the default location for container images and virtual machines are under var. And there's also a temp directory under var as well.
Yeah. Right. And all these things, like if you're a mail server, you might have a lot of mail in var spool mail. But if you're not a mail server, you won't have very much mail in var spool mail. Or if you're a
Mm.
server that does a lot of log entries, you could have a lot of stuff in var log. But if you're not a very active server, maybe you don't have a lot of stuff in var log. So that's why we put it under var here in Red Hat Enterprise Linux and Red Hat flavor distributions, because it's for variable length content. Depending on the use of the system, either in activity or software, there could be more or less stuff here, and we can't necessarily know that. That's also why a lot of security compliance standards have var separated out into its own backing disk device, because we want to be able to maybe fill up what's in var's disk, but not affect the other operations elsewhere on the system as well. All right, we're starting to close in on just a couple left.
And I like to take that a step further. Usually, if it's a web server or database server, I actually create a partition to separate out that content a little bit more. So if it's a web server, I like my web content to have its own partition. That way, if the virtual machine gets blown up, I can always just grab that partition and back it up somewhere else.
All right, proc. Proc is a weird one because it doesn't actually have a backing disk device.
So proc is interesting. You can see a lot of what's running in the kernel. So you can pull files within proc to see what hardware configurations are, what kernel parameters are. But I'm blanking on what proc actually stood for.
So I think originally it was named that way for process, because what it stores in there is process and kernel information. So if you just looked at the top level directory in proc, you'd see a bunch of numeric subdirectories. Those all correspond to the actual process IDs of processes running on the system. And you can go in those directories and see specific things about the processes themselves. But then there's also things like proc VM stat, which is giving you your virtual memory statistics on the system, or proc CPU info tells you about the processors that the kernel sees. And then the thing that we've talked about a couple times here on Into the Terminal already is proc sys. Proc sys is the tunable parameters for kernel, where you can make adjustments to the kernel behavior on the machine. So we've done things like change swappiness or set the file sync times for how often we should purge data out of file cache to the actual disk devices and stuff. All right. Oh, Etsy. That's a really important one. So Etsy is for config files, right? And originally in the background of Unix world, it was yeah, whatever. We'll just put the rest of the stuff there. And the rest of the stuff ended up being things like configurations or customizations to an application. And so it became where we put configuration files. So if I'm looking for a configuration file, that's probably my first stop. Oh, opt is a good one.
Yep.
Crowded
We're
here.
running out of room.
All right, this is for optional software. And so sometimes you'll see that third-party software that doesn't come distribution puts itself here. So that's a place where a third party can put a directory with all of their application-related files stored in it. And a lot of times you'll also have to do things like adjust the path environment variable for people so that they can find those executables that are stored there, because opt is not by default added to the path environment variable for users on the system. All right, sys.
I think we only have two left. Yep.
Yeah. I'm going to say sys. I'm going to lump it in there to process kernel. So sys is for system information, but specifically it's also stored in RAM and in the kernel's RAM. And it has things like the IO scheduler that we're using on the system and customized values, how we should operate it. So like proc, it exposes a segment of kernel-related data and information to us and subtunables that we can how the kernel is operating. But it's also stored ephemerally in memory, meaning that when we shut down the machine, anything we did in sys goes away. It's not persistently stored. All right, and then I think this is the last one. SRV. So on Red Hat Enterprise Linux, we don't do a lot with this directory. Right? SRV is for server or service-related content. Other Linux distributions, this is where you'd find things like their systemd unit files and stuff. We store all that stuff under etc because we view them as conf files, or we put them under the user directory because they're Unix system resources that go with a specific service that was installed. So with Red Hat Enterprise Linux, you will likely find that this directory is not used or empty. We don't really put stuff here, but it is part of the Linux File System Hierarchy Standard. So when we're talking about optional software with opt, well, third-party software may also put things here in SRV, in service or server, but we don't use it as part of the distribution.
And with that, we took a whirlwind tour of the file system, the Unix file system hierarchy, and a little bit about some of the difference between Unix, Linux, specifically RHEL. So not particularly deep today, but I think it really helps paint a picture of how systems are laid out, where to go looking for things if you're trying to run a command and you can't find it. At least now you've got a few directories that you can go and check, and also don't copy and paste quotation marks into lab.redhat because apparently it breaks. But no, I know we went a little bit long today, but I feel like it's good foundational material to have. With that said, we're going to go ahead and wrap up today's episode. If you like this content, go ahead and like and subscribe. Hit that. Go ahead and hit that bell so you get notified anytime we go live. Next week, I believe Scott and I will be back to talk about step-by-step to installing RHEL 9. We've provided some tools over the last few weeks between Kickstart Cloud Init, Image Builder, and I think I forgot one. But now we're going to take you step-by-step on installing RHEL 9. So with that said, on behalf of Scott McBrien, the entire Red Hat Enterprise Linux team, thank you all for joining us, and we'll see you next week.